The mechanical mates are actually my favorite kind of mates. They allow you to add in gear mates, cam mates, hinge mates, universal joints, as well as screws. So to get started, I'll go into mates, choose mechanical mate, and we'll start with a gear mate. So if I choose gear mate and choose two circular edges, in this case these two, it's going to set a ratio based on the diameters of these circles. Because I have two gears that have the same number of teeth, what circles I select don't matter too much because I can put in 1 to 1 if I want. I could also change this to 1 to 2, for example. But if you want to make it easier on yourself and you have gears with different numbers of teeth, you can add a pitched circle as a sketch and select those two out, and it'll bring in the correct ratio. If I click OK, you can see every one rotation I make of this gear, it rotates this gear twice. But what you'll also notice if you look closely, that these gears are colliding the entire time, or they're overlapping. So when you set up a gear mate, it's not going to automatically detect any collision or try to avoid collision. So before you create your gear mate, it's a good practice to either separate these or have them just contacting. And then you can come in and choose the gear mate, select out these two circles, and add that mate in. Now, unless I add another mate in, and it's harder to see, this cylinder isn't going to rotate. It's not going to rotate with this gear. This simply slides on top of it. So if I want these two to move together, I can actually add another gear mate. I'll select this inside circle and the outside circle, and I'll just make this ratio 1 to 1. And uncheck the reverse so they're going in the same direction. Click OK. And then we can come around to the other side and select out that edge and this edge. And once again, make it 1 to 1. Click OK. Now when we rotate the gears, both sides will rotate. Once again, I'll go ahead and start these off just barely touching or barely offset from each other, so they look just about right. If you wanted, you could use physical dynamics in this case, or collision detection, to get them right next to each other and then create the gear mate, but for all intents and purposes, this is good enough. So once again, I'm going to choose the gear mate. And in this case, I do have pitch circles for these gears. So if I open up this 12 DP gear and choose the sketch, I'll go ahead and show it. And I can click on it as one of the selections. And then for the pinion gear on the top, show the pitch circle and click on that. In this case, we'll want these reversing and click OK. And you can go ahead and just click on or right click on the sketches and say hide. To get those out. And now when I rotate this, That's actually reverse when it's not supposed to be. So I'll go ahead and edit this feature and uncheck the reverse. And now that should move in the correct direction. Once again, I'm going to want this shaft to move. So I'll select out another gear mate. And choose that circle and make these 1-to-1. Alternatively, I could have just made these two gears have a 1-to-1 ratio. And click OK. But either way works. Lastly, I want to make this cam also have a 1-to-1 ratio. So now when I move these all move. And it looks like that cam needs to be reversed so that these all go in the same direction. The next mate type we'll use is rack and pinion. So I'll go ahead and adjust the rack so that once again it looks like it's just touching. And for this, I'll need to show that pitch circle again. And we'll come into the mates, go into mechanical mate, choose rack and pinion. And for the rack, all we have to do is select the edge in which we'll have our motion. And for the pinion gear, just that pitch circle. And you see it brings in that pitch diameter. And click OK. And now we can see those two move together. And I'll go ahead and hide out the sketch. The next mate type is a cam mate. This is going to allow us to select a cam and a follower. So for the cam, you want to select whatever face that you want your follower to be coincident to. And then for the cam follower, you'll notice that I can't select this spherical face. So I actually went into the part and created a sketch point so that I could have something to be coincident to this face. So just keep that in mind when creating cam mate. You might need to create your own reference point in order to be able to use the mate. Now when we move this, you can see that that pin follows the cam. The next mating type is a screw mate. And this is going to allow you to take something like this screw or any cylindrical object, and every time you rotate it, it will move along the axis of both cylinders. So I'll go ahead and say view temporary axes, as we need to use the axes to create the mate. And we'll choose screw, choose this axis and this axis. And then you can specify a number of revolutions per inch. If you have, for example, 18 threads per inch, you can specify that. I'll keep this as 1 so it's a little bit easier to see the motion. and click OK. And you'll see as I move this down, it'll rotate on its own. And if I rotate it, or if I'm pulling in the direction of rotation, it'll also rotate. So that's two ways to move it. Pull up, it'll rotate itself, or pull in the direction of rotation. The next mate type is a hinge. And a hinge simply allows you to add two mates at once, a concentric relation and a coincident relation. It also allows you to add in an angle limit if you want as well. So I'll select out this face and the cylindrical face there. And I'm going to go ahead and make the bottom face and this top face coincident. I could come in and specify angle limits. I'll go ahead and leave this unchecked. If you are curious on how this works, you can go back into the advanced mate video and see how the angle limit mate works. And these two things work exactly the same. So if you learn how to do it there, you'll be able to come in and set up an angle limit in this assembly. I'll go ahead and uncheck that view temporary axes. And now we have that hinge mate, which is just the concentric and coincident mate together. The last mate among the mechanical mates is the universal joint. This is a mate that I actually don't use very frequently, just because if you do have a universal joint, you'll usually have the yoke that goes between to mate in, and so you won't need the universal joint mate to create the motion, as the mates you create between the yoke and the spider are going to define that relation on their own. But in the case where you don't have the spider in the middle, you can select out the two cylinders, click OK, and then these will rotate together. So that's how you create all of your mechanical mates. And these can be quite useful for showing motion within an assembly. Sensors can be used to monitor different parameters within the assembly as well as component environments. If I right-click into the Sensors folder, say Add Sensor, I have quite a few options. I'll go ahead and start with mass and click OK. And this is going to give me a sensor for the mass of the entire assembly. So if I were to hide this out and make a modification in one of these gears, let's say by adding an extruded cut, then that sensor is going to update within the assembly. And I can also set a parameter for it to alert me to. If the mass is greater than, let's say, 15 pounds, it's going to set an alert. Now if I go back into that gear and quickly create a pattern, it'll drop below that weight and that alert will go away. So I'll go ahead and go through the other parameters that you can set for the sensors, and for each one of them you can set an alert. If you don't want the mass to be above a certain quantity, you can set that as the alert. In this case we could even set it as less than If we need to stay at an exact mass, we can set that as well, and any of the other options as well. Within the mass properties, we can also select the volume, the surface area, or any of the centers of mass as a parameter to monitor. We can also look at simulation data if we want to see stress or any other parameter, and also want to set a factor of safety. We can do that as well. In this case, I can be notified if my factor of safety is lower than a certain value, 2 for example. I can also monitor dimension values. If I had dimensions showing, I could select one out, also set an alert, or just see how that dimension changes. We can use interference detection if we want to make sure that 2 components aren't colliding or several components aren't colliding. We can do that as well. This one, you just want to be sure that you're only selecting the components that you want to measure. If you select out too many components, you might slow down your assembly significantly. We can also choose a measurement. If I measure out a distance in here, for example, I can save out that measurement, and we can monitor that as well as setting a proximity sensor. So if we don't want a certain component getting too close to another, for example, if we didn't want this gear getting too close to the edge of the gearbox, we can set a proximity parameter as well. But that's how you use these sensors, and they can allow you to quickly monitor various parameters within both the assembly and the part environment.